At this point, you know how to measure masses of pure solids and volume of pure liquids and solutions. We've also talked about how to convert these measurements into moles, which are the heart of most of our chemistry calculations. In this unit, we'll discuss gases, and it turns out that we need a little more information to fully measure amounts of gases. The amount of gas present in any situation depends on the volume of the gas, the temperature, and the pressure. We'll start by talking a little more about pressure. In general, pressure is a measure of force exerted over a given area. Remember that gases are made up of particles that are moving rapidly relative to each other. As these particles move, they collide with each other, but they also will collide with the surfaces that surround them. And when we talk about gas pressure, we really are talking about a measure of the force exerted by gas particles colliding with the surfaces around them. The more collisions per unit surface area, the greater the pressure. So the concept of gas pressure is pretty common in our everyday life. When you listen to the weather report and you hear mention of high pressure and low pressure systems, what they're really referring to is the pressure of the atmospheric gases above us. In high pressure systems, there are generally more gas particles. That means more collisions and a greater force per unit surface area for those gas particles. In low pressure systems, on the other hand, there are generally fewer particles, so fewer collisions and less force per unit surface area. And air in the atmosphere is generally pushed from areas of high pressure to areas of low pressure, and this creates the wind that ultimately governs our weather systems. Air pressure is commonly measured using a barometer, and this is a picture of a mercury barometer. It's a thin glass tube that's closed at one end and filled with mercury. The tube is then inverted and immersed into an open container of liquid mercury. And the gas in the atmosphere exerts a pressure on the surface of this open container of mercury. Gas particles collide with the surface and exert a force, and that force actually pushes the liquid up the tube. At the same time, the weight of the liquid in the tube exerts a force in the opposite direction. So this is associated with the force of gravity acting on the mass of the liquid mercury in that tube. The height of the liquid inside the tube is actually a balance between the force exerted by the atmosphere, pushing on the liquid outside the tube and pushing it up into the tube, and the weight of that liquid mercury pushing down. So the greater the atmospheric pressure, the higher the liquid can rise up the tube. And we can actually measure the height of that liquid as an indicator of atmospheric pressure. At sea level, which we use as a standard reference point for atmospheric pressure, the mercury will rise to 76 centimeters, or 760 millimeters. And this is the basis for one of our common units of pressure in chemistry, the millimeter of mercury, or mmHg. So this is also called a torr, after Evangelista Torricelli, the Italian physicist who built the first barometer back in the 1600s. There are a variety of other pressure units that you'll also encounter as we continue to study gases. The one that we'll use most frequently will be the atmosphere, abbreviated ATM. 1 atmosphere is defined as our reference point, the atmospheric pressure at sea level, and it's equal to 760 millimeters of mercury. The official metric unit of pressure is the Pascal, abbreviated PA, and it's equal to 1 Newton, which is the capital N, and it's the metric unit of force, divided by meter squared, which is the metric unit of surface area. The Pascal is actually a pretty small unit. It turns out that 1 atmosphere equals 101,325 pascals. There are two older units of pressure that you also may encounter. The first is inches of mercury, INHG. It's similar to millimeters of mercury. It's just in units of inches instead of millimeters. So 1 atmosphere equals 29.92 inches of mercury. Another one that you probably know from inflating your tires on your car is PSI. And PSI actually stands for pounds per square inch. So 1 atmosphere equals 14.7 PSI. And finally, a common unit used in meteorology is the bar. So a bar is actually equal to 100,000 pascals. So it's very close in magnitude to an atmosphere, but not quite as large. So you should be able to use these relationships to convert between any pressure units. And I won't make you memorize the conversion factors, but I do expect you to know where to find them and how to use them. So let's look at a sample conversion. A typical barometric pressure reading in Chicago is 740 millimeters of mercury. What's this pressure in atmospheres, and what is it in bars? Let's start with the atmospheric conversion. As with any unit conversion, we start with the number that we're given in the problem, 740 millimeters of mercury. And we look for a conversion factor that relates that to the unit we want, atmospheres. And there is actually one. 1 atmosphere equals 760 millimeters of mercury. So we multiply by our ratio so that millimeters of mercury cancels out. So the unit that goes with, or the number that goes with millimeters of mercury goes on the bottom, and 1 atmosphere, the unit we want, goes on top. We multiply by everything on top, divide by those numbers on bottom, and we get 0.97 atmospheres. You can do more complicated conversions as well. For example, to convert into bars, we don't have any direct conversion factor that relates bars to millimeters of mercury. Instead, we have one that relates to pascals, and then we have a relationship between pascals and atmospheres, and a relationship between atmospheres and millimeters of mercury. So we have to use all 3 conversion factors. We start at the same place, 740 millimeters of mercury, and we actually set up with the same conversion factor to begin with so that our millimeters of mercury cancel out, and we have a new unit of atmospheres. We can convert from atmospheres to pascals using our second conversion factor. And this time we set it up so atmospheres cancels out. So atmospheres is on the bottom of the second conversion factor, and pascals is on the top. And once we have pascals, we can then convert into bars using our final conversion factor. And again, we set this up so that pascals is on the bottom so that it will cancel out, and bar is on top. Multiply through by everything on top, divide by everything on the bottom, and we find that we have 0.99 bar for 740 millimeters of mercury. So in summary, pressure is a measure of force per unit area, and the higher the gas pressure, the more collisions between gas molecules and the surfaces surrounding them. We measure atmospheric pressure using barometers. And in the laboratory, we can use manometers to measure the pressure of gases collected in closed containers. Finally, there are a variety of gas pressure units in use today, and you should be able to convert between those using conversion factors.